This research paper proposes a novel inter-intra modal loss, (2 loss) to address the problem of false negative noise in self-supervised cross-modal retrieval tasks, particularly in video music retrieval. The 2 loss reduces the variation of feature distribution within the two modalities before and after the encoder, mitigating the model's overfitting to noisy data. The proposed framework, IICLVM, incorporates the 2 loss and achieves state-of-the-art performance on the YouTube 8M dataset. The paper highlights the limitations of existing self-supervised learning methods, which assume one-tune matches between video and music samples. In reality, a video can use different music as background music, and a music can be used as background music for different videos, leading to false negative noise in the dataset. The 2 loss addresses this issue by minimizing drastic variations in feature distributions within each modality, enabling the retrieval models to generalize better. The IICLVM framework employs global sparse (GS) sampling, allowing music retrieval to be based on the content of the complete video rather than fixed-duration video clips. The framework can also easily integrate multimodal video information, such as images and text, to achieve better performance. The paper reviews related work in contrastive learning and cross-modal retrieval, including clip, clip-for-clip, and audio clip, which use large-scale datasets to self-supervise the pre-training of encoders for image text and video text retrieval tasks. Other works have explored different pre-training methods, loss functions, and optimization techniques for cross-modal retrieval tasks. In the context of background music selection for videos, the paper discusses the importance of emotion, location, style, and genre, as well as user personality and comments, in music video retrieval. Recent works have employed self-supervised contrastive learning methods to learn rich factors and preferences of video creators to choose background music automatically. The paper also reviews the use of pre-trained visual and audio feature extractors in video music retrieval tasks, highlighting the importance of feature extractor performance in restricting retrieval performance. The proposed framework, IICLVM, Inter-Intra Contrastive Learning for Video Music Retrieval, aims to enhance video music retrieval by introducing an inter-intra modal loss. This loss function is designed to measure the distance between encoded video and music embeddings, while preserving the relative feature distribution of the 4 music samples in the encoder output. The framework utilizes global sparse sampling to extract features from the entire video and music, sequence encoders to extract temporal information, and the inter-intra modal loss to train the model. The intermodal loss is calculated based on the cosine similarity matrix, which increases values on the diagonal and decreases those in other positions. The intramodal loss is designed to maintain the distribution of features before and after encoding, preventing the distance of false negative sample pairs from increasing. The total loss is a weighted sum of intermodal and intramodal losses. Experiments on the YouTube 8M dataset show that IICLVM outperforms state-of-the-art methods in video music retrieval tasks. A subjective evaluation also confirms the effectiveness of IICLVM in selecting background music for videos. Furthermore, the generality of the 2 loss is verified on various cross-modal retrieval tasks, and experiments are conducted to alleviate the problem of false negative noise in retrieval datasets. The research paper discusses the video-to-music and music-to-video retrieval tasks using the IICLVM framework. It compares different sampling methods, including GS sampling, which significantly improves retrieval performance. The paper also evaluates the impact of the 2 loss in IICLVM, showing consistent improvements in retrieval performance across various sampling methods and encoders. Additionally, it presents subjective evaluation results, indicating that the model's selected music matches the video better than a random piece of music. The IICLVTM framework is also evaluated, demonstrating the effectiveness of using video and text together for music retrieval. Finally, the paper explores the generality of 2 loss on different cross-modal retrieval tasks, including audio text, image text, and video text datasets, showing significant improvements in retrieval performance. The paper presents a novel framework for video music retrieval tasks, leveraging the IICLVM model and its innovative 2 loss function. This loss function enhances the model's generalization capabilities by maintaining pre-trained feature distribution within the two modalities during training on noisy cross-modal datasets. The IICLVM framework has shown promising results in video music retrieval tasks, achieving state-of-the-art results on the YouTube 8M dataset. The addition of multimodal video information input, such as text, improves music retrieval performance in applications. Subjective evaluations also support the framework's strong performance in music selection. Beyond its application in the IICLVM framework for video music retrieval, the two-loss has proven to be valuable for other cross-modal retrieval tasks, such as image text, audio text, and video text retrieval. This showcases the adaptability and versatility of the two-loss in different contexts and applications. Moreover, two-loss is found to obtain good retrieval models with a small number of training samples. The paper also explores the effect of two-loss against false negative noise interference. Experiments on the YouTube 8M dataset and the Caltech 256 dataset demonstrate that two-loss can effectively resist the noise that exists in self-supervised retrieval tasks. As the noise increases, the two-loss group shows more and more improvement compared to the non-II loss group. In conclusion, the IICLVM framework with the two-loss function has shown promising results in video music retrieval tasks and has the potential to be applied to other cross-modal retrieval tasks. The adaptability and versatility of the two-loss make it a valuable tool for enhancing model generalization capabilities in noisy datasets. Here is a combined summary of pages 9 and 10 of the research paper. The paper discusses the significance of the two-loss in improving the performance of cross-modal retrieval models, particularly in tasks involving large datasets and noise-resistant methods. The authors highlight the potential of the two-loss in becoming a more effective and versatile tool in the field of cross-modal retrieval. The paper presents a stacked bar chart, Fig. 7, that shows the relationship between the increment of R at K with or without two-loss and the noise level in the batch on the Caltech 256 dataset. The chart demonstrates that the R at K without two-loss drops rapidly as the noise level in the batch increases, while the effect of two-loss on improving R at K is significant when the noise level is high. The authors provide an extensive list of references, 3,743, that cover various topics in cross-modal retrieval, including music soundtrack generation, cross-modal ranking analysis, audio-visual embedding, and video music retrieval. These references demonstrate the breadth of research in the field and the importance of developing effective methods for cross-modal retrieval. The paper also references several key papers in the field of computer vision and natural language processing, including works on deep residual learning, transformers for image recognition, and video recognition models. These references highlight the importance of leveraging advances in these fields to improve cross-modal retrieval models. Overall, the paper emphasizes the significance of the two-loss in improving the performance of cross-modal retrieval models and highlights the need for further research in this area. The authors provide a comprehensive overview of the field, covering various topics and referencing key papers that have contributed to the development of cross-modal retrieval models.